Okay, we're letting everybody in. All right, thanks everybody for coming today. My name is Bradley Voytek. I'm a faculty member at UC San Diego in cognitive science and the data sciences program at the Halighiolu Data Science Institute. And I'm also one of the board members for the Data Science Alliance. I'm stepping up for Bahija Humphrey, our CEO today, who is on maternity leave. She just had her first baby a couple weeks ago now. And so I'm really excited to be presenting this workshop. I'm not doing anything. I'm here to just hand it off to our amazing undergraduate data science student society students. So at UC San Diego, there's the Data Science Student Society organization that formed in fall of 2014 after I had taught the first undergraduate data science class there. And that organization has grown from the initial, I want to say 6 people to a lot. I think the Facebook group has well over 1,000 people on it now. And I would say there's easily dozens of active students in that program. And before I hand that over to them, I am going to talk very briefly about the Data Science Alliance. So hopefully everybody can see this. So the Data Science Alliance is a local nonprofit that was formed just within the last year. And the Data Science Alliance, as a board member, we formed this with quite a number of folks involved in the data sciences in San Diego, both on the entrepreneurship and startup side, industry side, academic side. And our CEO, Bahija Humphrey, comes from the city of San Diego, where she formerly led program performance and analytics, I believe, for the city of San Diego. And so the reason that we formed this organization is that data science is encroaching upon pretty much every aspect of our lives. And when I started teaching data science to the undergraduates in 2014, I talked a lot about social media and the role that data collection was playing in social organizations and social structures and politics. And I believe in the last couple of months, it has only become more and more pressingly obvious. And so if we are going to be training the next generation of data scientists in ethical, useful, problem-oriented data science and teaching them how to come up with solutions requires a multifaceted approach. It's not just a undergraduate education issue, which is what the UC San Diego program is solving. It's not just academic research, which is also UC San Diego and other universities. It's not just an industry problem. It's not just an entrepreneurship problem. It's not just a government problem. It's not just a military problem. It's an everything problem. And so we need better approaches to solving these kinds of problems. So the Data Science Alliance, its goal is to try and improve the way that we use data to drive decisions and to attract and retain top talent in San Diego. Bring them to San Diego, and once they're here, keep them here, and to try and help solve marquee civic and business problems. So this Data Science Alliance brings together all these people along with a variety of different kinds of data sets to, try and change the world. That's the goal, right? That's always the hope. And it's through the combination of problem solving, talent development, and business investment. And so with data science, we argue that we can solve these kinds of marquee civic and business problems by harnessing large data sets and identifying trends within them, gathering insights from multiple sources to try and tackle some big challenges, attracting and retaining top talent. So advancing San Diego's innovation sector in the data sciences and beyond, and then train and develop skills for future work. So data science isn't just a learn a couple of skills and then that's your career. It's learning the skills and continue to develop. Data science is a rapidly developing field. There's constantly new methods and approaches and tools being used. And then finally, using data to try and drive decisions. So allocating resources, measuring performance, using real-time data to power predictive models in pretty much every domain you can imagine. And so, this Data Science Alliance community that we're trying to build is an attempt to bring together folks on the business side, integrating data science in existing businesses and fueling momentum for new startups, trying to then also incorporate that with the talent development to increase opportunity and set more data scientists to solve problems, while also doing this problem solving of solving these marquee civic issues. And so this problem solving as a nonprofit data authority in San Diego, we want to try and implement a new model for solving these problems. So guide and inform policy decision-making, uncovering truth about through evidence and fact, identifying opportunities proactively, and then reducing uncertainty and increasing transparency. And talent development, we want to create a talent pipeline that is connected to industry. So through retention, so try and curtail some brain drain. San Diego has one of the best research universities in the country in both the engineering and biosciences. And a lot of our folks who get trained here, they leave, and we want to try and keep them here. And in order to do that, you have to attract talent, attract some large organizations that can bring in people, hire people, and keep some of our people here. And that's partly done also through the development. So encourage continued growth in the startup ecosystem, as well as in established industries, and also in government and other nonprofits. And part of the way that we do that is through business investment. So identifying and catalyzing new opportunities that involve here integrating data science into existing businesses, establishing new startups based on data science related gaps in the ecosystem, which then all come together to create a fertile ground for innovation in data science. And so we're forming this council of advisors, which is a commanding group of leaders and visionaries in industry and beyond. It's a collaboration of all of these innovators that bring a diversity of experience, both successes and failures, from a variety of different backgrounds. And so why would you want to join this council? There are many opportunities. So one is problem solving. So the Data Science Alliance will help build this internal team of experts using data science to solve these problems. And talent development, like we said, will serve as a catalyst between talent and industry. And then in business development, we're hoping to propel investment in local companies and champion new startups. And so council members will help identify and prioritize the problems that we tackle. They'll have priority access to the talent, and the council will have the first right of refusal for any kind of investment. And so with that, I want to introduce you to the board, Taneri Ligiolu and Dr. Ilke Altintas, also at UC San Diego and the San Diego Supercomputer Center, myself, Ned Ligiolu and Andy White, who are pretty heavily involved in the San Diego startup and entrepreneurship scenes. And our CEO is Bahija Humphrey, our Chief Technical Officer, CTO is Alex Bates, our CFO is James Kelly, and Gina Harris is our board secretary. And so if you want to discuss how to join our council of advisors, you can try and find time to meet either Bahija Humphrey, like I said, she's on maternity leave. If you email Bahija, that'll go to Jenny Bustance, who's our interim CEO for taking Bahija's place while Bahija's on maternity leave. And that's it. So I'm going to hand it over now to Sravya. Sravya Valetti is the president of the San Diego Data Science Student Society. And I could not be more delighted to hand everything over to them today, because the work that they are doing is truly remarkable and impressive. And I wanted the undergraduates that we are training in San Diego in the data science to really be able to show off the kinds of things that they're learning and the kind of really remarkable and unique work that they're doing as a critical component of the San Diego data science ecosystem. And so with that, I'm going to stop sharing. And Sravya, I'm going to highlight you. All right, take it away, Sravya.
Hi everyone. Thank you for the introduction, Professor Voytek. And hi and welcome. So my name is Sravya, and I am the president of the Data Science Student Society at UCSD. Next slide, please. So just quickly going over our agenda for the workshop. First, we're going to discuss what is DS3, what our mission is. After that, we're going to have a quick workshop where we go over a couple different data science topics, such as neural networks, natural language processing, and sentiment analysis. And finally, we'll wrap up with a couple of teams from our project committee, and they're going to present the projects that they've been working on last quarter. Next slide, please. So first, what is DS3? DS3 is an undergraduate student society at UCSD for students of all majors and skill levels. We hold both social and professional events throughout the school year where students can connect with other students with similar interests, meet with industry professionals, and build their data science skill set. Some of these events include our Talent Day, which is a career fair specifically for students interested in careers in data science, and our Another big event that we have is Data Hacks, which is a hackathon where students form teams and work together to analyze the provided data sets and draw conclusions. We also hold workshops throughout the year where students can learn various data science skills, like the workshop that we're about to host later today. We also have a projects committee where students can collaborate on group projects and then present them at our annual projects showcase. Last, we also have a Medium page and a podcast where students can learn the diverse facets of data science. Next slide, please. So now I'm going to pass it over to Peter Peng, who is our workshops director, and I'm going to spotlight him.
Can you all hear me? All right, so I'm Peter. I'm the director of workshop, and definitely before switching gear to the actual project presentation, we're going to talk about some basic machine learning and those topics for people who have not heard of them or just want to refresh, right? So today we're going to first talk about machine learning. What is machine learning? So its purpose is to teach computers how to learn and act without being explicitly programmed, unlike those if-else statements you've heard before. That's not machine learning. And like the part that's highlighted, its essence is to capture the mathematical functions that best fit the data and to predict unseen data. It's the ability to generalize. And some common tests are regression, classification, and also ranking. Regression is to predict continuous values, such as the miles per gallon, given the car's features. Classification is to predict finite and discrete values. It can be binary or multi-class, such as given a feature of a dog, you want to predict what kind of breed it is. And lastly, ranking. It is often used in recommender system, and it basically aims to order the items in a list by its relevance. For example, like given TikTok videos and just a bunch of videos, and the system trying to sort them in the order that will best fit the user's preference. And then we have neural networks. It is created to mimic the human brains, but we're not going to go too much in detail of that. Just to know that its essence is to analyze input layers by layers, and each layer progressively extract higher level of information about the input. So on the right, you can see this is a diagram of a typical neural network. It has multiple layers. In the first one, or on the far left is the input, far right is output. In the middle, we call it the hidden layers. It can, you guys can customize it. You can add different layers or how many ever you want and how many nodes you want. What differs from machine learning is that neural networks actually have something called the activation function. It adds non-linearity to the model. And on the left, you can see a simple representation of the true value and the predicted value by a neural network. You can see it really tightly fits the actual value instead of a linear model, which would be this slant straight line. So that's the perk of neural networks. And we're going to go through some pros and cons quickly. So its performance is definitely impeccable, and it increases with the amount of data you have. And sometimes you don't even need pre-processing or feature engineering because it learns from previous features, and as you add more layers, it's gonna be more useful. And then it's very versatile in some of the most advanced research in natural language processing, computer vision, all sorts of stuff. They all use neural networks, and that gives us a problem as well, because as you can see on the right, sometimes it's very hard to explain what the model learns. Therefore, it's going to create some problem. And since it's very complex, as you can see, there's so many nodes as well as weights, it tends to overfit, and which renders another problem. It's going to be a slower training speed. As you can see on the right here, it would take like 30 GPU days to train this specific task. And yeah, it requires lots more computing power and resources. So definitely pay attention to your use case and then change from there. Yeah.
So you want to take me to take this one?
Go ahead.
All right, so hi guys, my name is Tanvir. I'm the machine learning workshops lead here at DS3. So we're going to kind of go up here, switch gears a little bit and talk about recurrent neural networks, which are basically a way of using neural networks to solve sequential problems, where you can take variable length inputs such as sentences or video and perform machine learning tasks on them. So if we're working with natural language, for example, we will, after this slide, also learn more about word representations you can use. And the most ideal thing to use with recurrent neural networks is word embeddings, which we'll talk more about on the next slide. But as you can also see at the bottom, recurrent neural networks are really nice because you can perform all sorts of different machine learning tasks with them, and you can customize their structure to do things such as text classification, machine translation, or even generating text. So that's really useful. And then obviously, to be able to take text and to be actually able to compute on it, the computer needs to be able to have a numerical representation of language. And these are some of such representations you can use with your recurrent neural network models. So the most naive representation of language you could possibly use is just using simple one-hot encodings, where you have, let's say, a vocabulary size of 40,000, right? And you put a 1 in that vector to indicate which word you are using from that vocabulary. And then another representation you can use is using n-grams, where you simply one-hot encode unique pairs or unique trios of words, as you can see right there. And last but not least, what's the most commonly used representation of language in industry right now are word embeddings. And people have created word embeddings through basically framing other machine learning tasks. And some of the most example word embeddings you can see right here are Word2Vec, Glove, or Elmo, and there are plenty more than just that. So we'll also talk about what is the word embedding. The idea is word embeddings are basically high dimensional representations of words. So you basically take a word and are able to then convert it to a 100-dimensional or 300-dimensional vector. And due to the how these word embeddings are trained with machine learning, word embeddings can obviously have really, really nice vector properties. So if you're maybe dealing with a word such as computer, right? You can also find other words in your vocabulary that have very high cosine similarities to that word. So if you guys want a little demo of it, you guys can go to that projector.tensorflow link right there, and you can see kind of the special properties that some of these words have in the high dimensional space. And last but not least, we'll talk about sentiment analysis. So sentiment analysis is basically a binary classification task you guys can perform on natural language using recurrent neural networks. And the goal of it is to quantify how positive or negative an input text is by outputting basically a probability from 0 to 1, where 0 is basically a very, very negative statement and 1 is a really, really positive statement. So you guys can kind of read examples of what a positive or negative statement would be, maybe somebody leaving a really good or really negative review on Google Maps or something like that. And in the industry, sentiment analysis is used a lot for analyzing customer feedback, because that's a lot of data coming in, right? And no human has is able to read through all the different customer reviews left on Amazon and all that sort of stuff. So automating it using sentiment analysis is really useful for companies. And another thing it's commonly used for is also monitoring brand reputation and social media. So this can be used for public relations by companies. But as you'll also learn from the project groups that are about to present, many investors or traders also use sentiment analysis as an indicator of stock prices. So that way you can map brand reputation to, how a brand stock price might move the next day. So you guys learn more about that.
Hi everyone, my name is Peter. I am the projects director for DS3's projects committee, and we're going to showcase 3 of the projects that have been going on this quarter. They began in the fall actually, and they'll be showcasing all the hard work they've been doing. So we'll have first stock price sentiment analysis with Twitter comments go first, and then following that we'll have applying neural networks to classify and predict molecular activity, headed by Karthik. And finally, we'll have fair policing analysis in Chicago. And so these groups will be presenting, and you will have a Q&A afterwards to ask them and give feedback on anything you might have questions about. But without further ado, Maitreyi, you can start presenting your stock price analysis.
Thank you. Hi, I'm Maitreyi.
I'm Kevin.
I'm Rishabh.
I'm Xavier.
So the main idea of our project is to be able to explain the gap between the actual stock prices and the predictions that we make using LSTM or a RIMA using sentiment analysis. And now Xavier will explain our approach in further detail.
Thank you. So as we know, time series model is kind of a traditional way to approach the stock market predictions, but we can see that there are discrepancies between the actual prediction and the prices. So our project aims to finding some explanation for this difference, and namely what is missing in the time series model. And it turns out that time series model only looks into historical trend, and that is not all we want to know about stock price changes. And what is missing is the breaking news that will happen every day and that's not taken into account. So that motivates us to think, is there also a quantifiable way to connect the breaking news to the stock price changes so that we can kind of make up with these discrepancies? But first of all, we figured that it's super difficult to find the direct impact of news on stock price changes. So we take a step back and look at the chain of reasonings behind this. And fortunately, we find that the comments under news can be think of as some random samples about the stock traders' attitudes. So if we can find a quantified market sentiment out of the comments, we'll be able to use this value to fulfill the puzzle. So in general, we're trying to figure out if the inclusion of the market sentiment can improve the performance of our time series model on price prediction task. And next we have Rishabh talking about data collection and preparation.
All right, thank you, Xavier. So I was in charge of data collection and preparation for this project. And before we can start collecting any data, we had to choose the stocks we wanted to monitor. And the two important criteria we had when choosing these stocks was we wanted these stocks to have decisive price movement. We didn't want like 0.4 minus 0.4% days. We wanted +2 minus 3% days. And they needed to have a large body of Twitter data. So these stocks had to be discussed widely across the internet. And the stocks we ended up going with were what are known as the FANG stocks, which are Facebook, Apple, Amazon, Netflix, Google, and Tesla, which was more out of personal interest. So getting stock data on the internet is obviously really easy, like it's everywhere. So we ended up going with the Y Finance Python package. And here's an example of the data we got from Netflix from the 2nd of January, 2020 to the 13th of November. Getting Twitter data was a little more difficult. We couldn't use the Twitter API because we couldn't, the Twitter API only lets you access tweets from about a week ago. So we went to the data science librarian here at UCSD and she gave us access to the UCSD Brandwatch account. And so when we were querying these tweets, we wanted tweets that were directly interacting with the companies. So we queried tweets that tweeted at any of our company's Twitter handles. And an example of like a positive tweet we might have gotten is at Apple, loving the new iPhone 12. And an example of a negative tweet, something like Google Maps left me in a ditch somewhere at Google. And we exported a total of 80,000 tweets from our population size of 21 million. So here we have two graphs. The top one is the population, is the time series of the population. The bottom one is the tweets we sampled. And we tried to get a roughly random sample of the total population, as you can see from the corresponding peaks in both graphs. So next is Maitreyi with the machine learning portion of our project.
So the objective was to train like a deep neural network model to do the sentiment analysis for us. So we used the Spacey library to use the Voytek model by Google to train our model. And then we converted, we wanted to convert the sentences that we had into word vectors. So so you actually take like the average of the word vectors of the words present in that sentence. Our training data had a size of 1.6 million tweets, and then those tweets were converted into 300 dimension vectors, and then they were used as inputs for the model. So we had 300 inputs and 2 outputs, which was like the probability that a tweet is positive or negative. And then we trained our deep neural network model using trial and error, and we decided to put in 7 different hidden layers, and then with their heights shaped in like an hourglass shape. And then we also wanted to decide like the sentiment for a particular day, depending on all the sentiments that we predicted for that particular day. And then we decided to use all possible combinations and kind of figure out which one works the best. So the binary sentiment tells you if like the sentiment is either positive or negative. So it's a binary value. And the probabilistic sentiment is a more continuous version of that, where it gives you the probability that a particular tweet is positive. And then we use that in our predictions. And now Kevin will go over the results and the visualizations.
Hello. So first, I'd like to start by showing our resulting sentiment values for each company through the year. Since these are all FANG stocks, I think generally we'd expect them to move together. And while there's some small discrepancies in general, I think it holds pretty true. One thing we found pretty interesting was that each company had very different averages. So we can see like that Facebook's averages is actually below 0, while Apple's is all the way at 0.3 to 0.4. So we found that interesting. For the next graph, so we're going to compare the ARIMA prediction to the actual for Apple. So especially for the first half, we can see that the ARIMA is actually doing a pretty good job here. So the predicted is pretty close to the actual, doing good. But we get to the second half and it definitely becomes a little bit more unclear what exactly is happening here. There's some very large discrepancies here. And in fact, even in the second half, it appears that the ARIMA is sometimes predicting the previous day. So it almost appears to be like one day shifted. So we found that a little weird. And the next graph, we will take the difference between the ARIMA and the actual. Yeah. So a very big outlier like the one on August 17th, that would imply that the actual was much higher than the predicted. And likewise, a very low outlier like the one on the 6th would imply that the actual price was much lower than the predicted. And hopefully we can explain these with our sentiment. So now that we overlay the sentiment, obviously there's a lot of noise here, but in general, I think we have some pretty strong results. So we can see like on the major spike around the 28th, as the price movement moves up, we can see that our binary mean or our sentiment mean is following. And as the price moves down, we can see that our sentiment similarly follows. It should be noted, it's a little bit unclear whether the sentiment is moving like as some sort of a response to the price movement or as some sort of preluding catalyst. For example, on the 28th, the sentiment appears to respond after the initial price movement. But for some of the smaller spikes, like the one on September 6th, we can see that the sentiment responds before. So it's a little bit unclear. Either way, though, it definitely does appear like there's a strong correlation between the binary mean or our sentiment mean and the difference between the ARIMA and the actual. Now I will turn it over to Maitri Yi for future improvements.
So now we're currently working on getting better data because we figured out that actually Reddit comments have a stronger reference to the stocks that we're working with. So we want to be able to integrate these comments with the Twitter comments that we have and build a new training set for our model. And then we also want to use a better model like the LSTM instead of ARIMA, which gives you better predictions. And then we also want to be able to verify the results that we got. So we want to use the LSTM predictions and our sentiment as inputs to a different model that will predict the stock prices, and then compare those predicted stock prices with the actual ones to verify our results. Thank you for listening, everyone.
Thank you.
Awesome. Now we're going to open it up to any questions that the audience may have.
One person has their hand raised.
Doc.
Yeah.
Go ahead.
Hi, great presentation. Thank you for that. I just had one question. So this is what I've heard from reports that around 90% of the traders are not right. So all of these I'm considering a fair amount of them would be on Twitter as well, like an assumption. So most of these people get beaten by the market, and their sentiments are actually, that would also mean that the sentiments for the stock price fluctuations would be inaccurate as well, considering they're getting 90% of them are getting beaten by the market. So how do you take that into account, considering that majority of your data comes from Twitter itself, and most of the people on Twitter are getting beaten by the market?
So the thing is, we realize that Twitter is actually not a very reliable platform. Also, we kind of we don't take all the tweets that there are. We only take the tweets that kind of have an impact. So then, if they have like a particular amount of influence, or like if they have like a particular amount of likes or dislikes, that's when we consider that tweet to be actually impactful and helpful towards the prediction. And that's how we kind of got our tweets in as well. If that answers your question.
Yeah, that was a great answer. What I made out of that answer is basically you take the number of likes, or whether, let's say, an account is verified or not on Twitter, based on how you filtered the data out.
Right.
Okay.
Yeah, and we also want to move, like I said, we want to move to a different platform, because those tweets are they, like I said, they have a stronger reference, which means that they target the stock prices more than the Twitter does, because they're kind of more generalized, and it doesn't have a lot of value, actual value kind of
I see. Yeah.
to consider. Yeah.
Thank you.
Thank you.
Nicholas?
There we go. Yeah, I guess I had like two questions. I guess one was, how far ahead was ARIMA able to predict the stock trend? Were you able to draw the graph completely that you just showed, and then it kind of followed over the course of the weeks, or was it day by day, like incremental?
For now, it's just predicting the future one-day price, and if once we gather the exact price of that day, we can predict the future. So like one-day future each step. So like we are predicting tomorrow's price every day.
Okay, cool. And then I guess like my second question was, in mentioning that like Reddit, I guess, had a bit more of a stronger correlation to the comments were a bit better. Do you guys plan on, or have you tried other platforms like Facebook? And I don't know how you would scrape TikTok, but have you guys tried other platforms, and if you have they been better or worse?
I don't think we've actually considered Facebook before, but I think about the data, I think Rishabh will be able to tell you more about that.
Yeah, I'm not too sure how we would scrape TikTok, but we started only with Twitter, right? Reddit is kind of an add-on now. I don't think we would want to, I don't think we're planning on scraping Facebook at all. We have the resources to do so, but I don't think we're planning on doing that anytime soon, if that answers your question.
Is there like a particular reason? It's just not as, it's too diluted, or?
Yeah, I think there's too much noise on Facebook, especially.
Sure.
The nice thing about Reddit as well is that there's certain communities that are like directly in reference to like the stock market in particular, right? So, on Twitter, like there's so much noise, like where people are just complaining about their broken iPhone or something, but a lot of these communities are specifically about like the stock and like how it's moving. And so we think it's a little bit more predictive.
Cool. Thank you, guys. Great project.
Thank you.
Thank you. Thank you for your feedback as well.
It looks like Doc has another question.
Yeah, very quickly.
So by when you said Reddit communities, I assume you also meant Wall Street Bets.
Yes.
Yeah. So you said you also have the tools to include like social media platforms like Facebook. So how do they have like a separate API for that, or so how do you do that? So just wondering.
Well, the third-party service we use, which is Brandwatch, gives us access. So basically any query we make, we can do to Instagram, Facebook, Reddit, a bunch of blogs online. So we have these resources. We just have to choose which ones we want based on, the queries we have. So
I see.
I don't know if that answers your question.
Is Brandwatch accessible? How do you access Brandwatch? Just through UCSD? How do you do that?
Yeah, we're on the UCSD account. So if you contact the data science librarian, Miss Stephanie LeBou here, she'll give you the next steps to access it.
Okay, yeah, thanks.
All right, thank you.
And one final question, Tanvir.
Yeah, I kind of just wanted to ask like a follow-up to what the other previous question was. Have you guys ever considered maybe even like using like the sentiment from like breaking news articles, maybe not just like social media?
Yes, we were definitely considering using that. Before we even started Twitter, we wanted to actually use news. But I think the main thing was we didn't have a lot of data coming from the news. We thought that Twitter would give us way more data than news would probably be able to provide.
That makes sense.
So we kind of switched to Twitter instead.
Yeah, and to
The
my
question-
knowledge, oh, sorry.
Oh, no, go ahead.
So to my knowledge, I think some professional investment companies will use human resources to label this news, like how this news will impact on the market. So it's like, we figured that it's quite a relatively difficult task for us networks to do. So yeah, we'll take a step back there.
Did you weight any of the features by how many likes or upvotes or retweets or anything they got?
Yeah, I think we made a filter when we pick the data, but for future weighted, I think we haven't done that, but we have the record here. Like we may try to see how that will improve our results in the future.
Awesome. Thank you, guys. Up next, we have the Repurpose AI group. So this group actually worked in collaboration with a company called Repurpose AI. And so they used their data and as well as had access to some of the individuals within the company. So they also got domain knowledge. And here they're going to showcase their project, which is applying neural networks to classify and predict molecular activity. And this is headed by Karthik. You can go ahead.
All right, let me see if I can share my screen. All right, awesome. I think I should be sharing. Hello, everyone. My name is Karthik, and I was the project lead for the, as Peter mentioned, the industry collaboration project with Repurpose AI. And what we worked on for this past quarter was working towards applying neural networks to classify and predict molecular activity. So I'm joined here by my wonderful teammates, Vineet and Ishan, and now I'll hand it over to Vineet to talk a little bit more about Repurpose AI as a company.
Yeah, so prior to actually talking about our specific project, I'll talk about Repurpose. So basically, Repurpose is a AI company that works in the pharmaceutical industry. And what they do is they expedite the time to actually create phase 2 and phase 3 drugs. So the way they do this is they use formulas that have already been made for like existing drugs. And there's a lot of good databases that have data for these existing drugs, such as Chembl, PubChem, and DrugBank. And they use these to create new phase 2 and phase 3 candidates for drugs. And the main advantage to this is obviously that it's much faster, like the drug creation process. And also that we have the ability to look at a lot more features in our data sets in comparison to traditional drug discovery, because a lot of the filtering mechanisms that exist in the traditional drug discovery market don't look at a lot of features like how Repurpose does. So with that, I'll hand it off to Ishan to talk more specifically about our project.
So thanks. So for our project, we wanted to find anti-COVID drugs that can, and for how we're going to do that is basically, so COVID, the virus, has lots of steps at which it interacts with the human cell. And at the very first stage, how it basically enters the cell is it interacts or binds basically with this ACE2 receptor, this protein. And if we could change the ACE2 receptor somehow, that could prevent the cell entry. So we endeavor to find drugs that target the ACE2 protein. That changes the ACE2 protein in a way that COVID can't enter the cell, basically. And for that, we're going to use an AI model to predict the activity with ACE2 receptor. Next slide.
Yeah, and so one unique aspect of our project is that we had the ability to use this IDE called NIME, which is a graphical interface that exists for especially a lot of like bioinformatics type projects. And you can kind of see a diagram below, and we'll go more specifically on a couple of those different workflows in our next slides. But basically, the way it works is there's these nodes that each have individual tasks. Like for example, there's a node that extracts data from a certain database. There's a nodes that filter data. There's even nodes that create models. And one of the biggest advantages to this is the cross-platform integration that exists. And what that means is just that you can have a model that like uses Pandas, also uses TensorFlow, and all of those compatibilities already exist within NIME. So it's very easy to use. You don't need a lot of coding ability necessarily to use it because a lot of it is very graphical. Yeah, and with that, I'll hand it back to Ishan to talk about our workflows.
Right, so for our project, we wish to use the Campbell database as our source, and we query the records of all the molecules that are known to target the ACE2 protein, and then we'll explain each workflow in detail as we go on. Right, so for the first step, we're going to download the Campbell bioactivity data, and we get all the molecules that target the ACE2 receptor, and then we clean the data based on missing values and duplicates, and standardize all the physical quantities, the metrics that we're using for our model. And in the slide, you can see that how NIME makes it super easy to do that. We give the Campbell ID for ACE2, and then we all the steps that follow. And further on, Karthik will explain the remaining 2 steps of our project.
Yeah, so I guess I'll be explaining the second and third workflows that we aggregated together to basically form our project. And the second workflow was focused around ADME screening, which stands for absorption, distribution, metabolism, and excretion. And so what we used a cheminformatics toolkit called RDKit, which is open source. And we used it to take basically the molecular structures and formulas that you get from the Campbell database and calculate some important molecular characteristics like the molecular weight, hydrogen bonds, and acidic and basic properties, which are very important for sort of finding drug candidates. And then what we did in our project specifically, basing it off of pre-existing NIME workflows, was we used a rule called Lipinski's Rule of 5, which was developed by a scientist named Lipinski at one of the major biotech companies, which basically sort of defines some if-then or if-else statements that basically say, oh, these types of molecules are more likely to be drug-like. And it's sort of just this universal rule. And we applied that to our data that we got for the ACE2 receptor. However, eventually, I think kind of tying into what Vineet was mentioning earlier about repurpose AI's goal, ideally we would want to move away from a manual rule like this and instead allow the algorithm itself to pick the rules that it uses and sort of allow for more eligible candidates for molecules that can become drugs. And so this is what one step of workflow 2 looks like within NIME. So this is just calculating the molecular characteristics using RDKit from the Campbell. And so here's the input, and then after that, it goes in through some RDKit nodes, which are built into NIME, and then we get the output, which we then use to perform screening using Lipinski's Rule of 5. Then the third workflow we used was our neural network model, which essentially classifies the molecules. And so the first step was to once again use RDKit to generate labels for the molecules and say which ones are going to be active and which ones are not going to be active. And then after that, our goal was to take a Keras network, which is another library built into NIME. And then we wanted to use the neural network to make predictions. And this is still kind of a work in progress. And then we're trying to evaluate this neural network using an ROC curve. And so this is what workflow 3 kind of looks like for the first two steps. So this is just using RDKit once again to label the data for training and test data. And then eventually we feed it into a neural network, which within NIME looks something like this, where we partition the data, we feed it into the model, and then after that, we aggregate the data at the end and we generate an ROC curve. And we're still really in the early stages of kind of developing this neural network. So this is what our ROC curve looks like right now. It's not the most flashy, but I think our goal throughout this quarter is to sort of look more into different architectures and kind of work with our mentors at Repurpose AI and see how we can basically improve this ROC curve to start moving towards that top left of the graph. So yeah, that's all we have. Thank you so much for listening.
Awesome. Does anyone have any questions for this group? I guess I have a general question. How has it been trying to get the domain knowledge you need for this project, and specifically considering it's quite intensive?
I think it's pretty, I think it takes a little bit of time to wrap around, I think, because like obviously with the molecules, the way they come out of the database is sort of in like a certain notation and things like that. But I think one of the benefits of NIME, and I think that's one of the reasons why we use NIME, is that it kind of provides a layer of abstraction above that, to the point where we don't have to worry as much about the sort of the nitty gritty of every single variable, column, things like that. We can just sort of modify configurations, and then I think the NIME documentation and forums are also really, really helpful in that. And so we're sort of able to abstract away from the really low level domain knowledge. But then I guess, yeah, it still takes a little bit of time, but definitely NIME helps that process quite a bit, I think.
Does anyone else?
Also, actually, we didn't really get into all the metrics we had. There are existing workflows that we took a lot of inspiration from. So, and then it was easy to look at those particular metrics and then read about them and then understand what could be the significance of the different like chemical and physical quantities that we are looking at.
Does anyone else have any questions? Okay, thank you guys so much. Finally, we have fair policing analysis in Chicago, headed by Argument. So whenever you guys are ready, you can present.
Let me share my screen. Okay, yeah, this is our project. It is a fair policing analysis of the Chicago Police Department. I am Arman, and the team members are Kusha, Anika, and David. So to start off, a little bit about our data set. It spans from the year of 1940 all the way to 2017. It's got information on the demographics of Chicago, the profiles of officers, including the years that they served, any awards or promotions they received, their salaries, and also complaints registered against them and by them. Some obstacles we encountered in working with this data set was that the files were poorly named and the naming conventions changed over this long period of time. There's also a good chunk of missing data that we had to work around. So we're going to start off with an analysis of the demographics. So what we have here is a comparison of the racial breakdown of the city of Chicago and the Chicago Police Department. To the left here, we see that nearly 32% of Chicago's population is white. But in the Chicago PD, in the pie chart on the right, we see that it's made up of nearly 62% of white officers. So that's nearly double. There's a clear disparity, and it's pretty significant. When we compare the ranks of officers and their gender and their races, we see that white officers tend to be less likely to serve as low rank officers, as the purple bar here is lowest for white officers when compared to all other races. So white officers are most likely to get promoted. Similarly, here when we compare this disparity across genders, it's less pronounced than the racial one. However, it does exist. Male officers are more likely to get promoted than their female counterparts.
So next, we analyze the years served of officers of different races and ethnicities. Here we have an overlaid histogram of the number of years served of white, Black, and officers of other races in the Chicago Police Department. And some interesting aspects of this histogram are, first, there's a large portion of officers that only served one year or less. And this is especially prominent for the Hispanic and other officer group. Also, we notice that there's a sudden jump of officers that stopped working after around 20 years, along with a large concentration of officers that worked around 30 years. Digging deeper into this, we found that only 25% of Hispanic and officers of other ethnicities and races had usable data when it came to analyzing their years served, which may not be an entirely correct representation of the total population of this officer group in the Chicago Police Department. And because of this, we hypothesized that some of our data may be skewed. I also did some external research and found that after working 20 years, officers are eligible to receive a pension plan that starts at around 50% of their salary, with this percentage going up 2.5% every year after 20 years in the service. This maxes out after 30 years of service in the Chicago Police Department, or when an officer reaches 75% of their salary, which explains this peak at around 30 years. And we see a similar histogram in analyzing the breakdown of the years served of officers by gender. And in this, we used a total of 17,373 male officers and 2,702 female officers. We also saw some similar trends with a large proportion of officers, especially female officers, working less than 1 year, along with a sudden spike at 20 years. And this is again, mainly for female officers, and also a peak at around 30 years, which is greater for male officers. And it's especially apparent in this visualization that many officers are retiring to get the best benefits, which start again at around 20 years of service and end at around 30 years of service.
So then we analyze the difference in salaries between races and ethnicities for the Chicago PD. This box plot shows the distribution of salaries of the entire police force. And here we can see that on average, the salaries between all racial and ethnic groups are similar. But using hypothesis testing, we broke this down into comparing the salaries by officer rank. And here we found notable inequalities. Among the rank sergeant, for example, sergeants who are Hispanic or of other races tend to have a lower median salary than white and Black sergeants. And among the rank commander, white commanders had a significantly greater salary than Hispanic, other, and Black commanders. This indicates an income inequality in the higher ranks of the police force. And among the lower ranks, however, such as police officer, we found no statistically significant difference in income. We then analyzed the salaries of female and male officers, and as the plots show, the average salary among both genders for all ranks is similar.
Now I will be going over the analysis of complaints about Chicago police officers. Most of the complaints were filed by civilians and a handful of complaints were filed by other officers. In this bar graph, we can see the total number of complaints for officers of each race and ethnicity. Highlighted in the yellow box, we can clearly see that white officers received the majority of complaints, which was expected since white officers make up a larger percentage of the Chicago police force than any other race or ethnicity. This next slide is related to the previous slide and shows a proportion of officers with complaints to the total number of officers within each respective race and ethnicity. It is important to note that although white police officers had the most number of complaints, as seen in the last slide, just 64.7% of white officers received complaints, which is a smaller percentage compared to Black officers, Hispanic officers, and officers of other races and ethnicities. Now we'll compare the number of complaints by each gender. This bar graph shows that male officers received a greater number of complaints compared to female officers. We expected this to be the case since there are more male officers than females. This bar graph is related to the previous slide and shows the proportion of officers with complaints to the total number of officers within each respective gender. It was surprising to us that 66.7% of male officers received complaints compared to 74.7% for female officers. This slide talks about the use of excessive force as shown in the picture on the right. And in total, there was 244,000 records of complaints against the Chicago Police Department officers. Of those, 42,000 complaints, or 17.2% of all complaints, were for use of excessive force. Most notably, 98.2% of excessive force complaints resulted in no consequences or reprimands for the officers.
So finally, we want to dive into the real significance of our project and take a look at some of the key takeaways. To start, we identified two major problems in the Chicago PD. The first problem is that there are many major disparities in race and ethnicity and gender across salary, years served, rank, and many other variables in the Chicago PD. This is especially concerning to us because we believe that these disparities could also exist in police departments across the US. Another issue is the minimal disciplinary actions for officers with complaints, and this is especially highlighted for officers with complaints for excessive force. And moving to solutions, to approach the issue of major disparities in police departments, two simple solutions we thought of were implementing mandatory diversity training and hiring officers who are more representative of the city population. Also, increasing accountability for the use of excessive force is a must, and the use of body cameras and deployment of citizen review committees to review cases and hold officers accountable for their actions is absolutely necessary. And this area is especially relevant to society today as the world reacted to the brutal deaths of many innocent citizens like George Floyd and Breonna Taylor to police brutality.
So there are a couple of directions we'd like to take our project in moving forward. First, we'll collect and analyze more recent data from different police departments in the United States, and using it, find patterns in the way police departments operate and whether these operations have changed over time. For example, we could investigate the use of excessive force in different cities year by year. Finally, we'll use our data to build interactive geospatial visualizations to better communicate our findings to the public. Thank you.
Thank you guys so much. Excellent presentation. Due to the interest of time, we will not be having a Q&A for you guys' project. Apologies for that. But Saravia, would you like to give the closing statements for DS3?
Yeah, let's just pull up our last slide. Yeah, so thank you everyone for watching. We hope you guys enjoyed learning a bit more about DS3. You can find us on social media. We have like our Facebook, our Twitter, our Instagram, our Discord, our website, and our email listed to the side. So unfortunately, we can't have any more questions because we're out of time. But yeah, if you have any questions at all, please feel free to reach out to us on any of these platforms. Thank you all for joining, and we'll see you guys later. Bye.